Hello everyone, welcome to my channel. This is Manoj. In this video we are going to practice stack data structure, and we will be using Java because the good thing is that we need to write all the steps in the algorithms. So in stack data structure, the way that we write is it's either based on an array or a list. Remember that it's either one of these two. It's either an array or a node. So, and the most common one that you will see is the array, and each one has its pros and cons. One is good at accessing data, the other one is good at just inserting data and then resizing. All these things matter, but that's another discussion. But let's take a look what the stack is. If you have an array based stack, in Java you have to tell the size of an array before you're creating that. So you have to give it a size. You can definitely resize something that you have created, but that would mean that you have the old array and then you will create a new array that will be much bigger than the old one, so the new one. And that means you loop through this and you copy all of these. So copy all of these data from the old array to the new array. And that means at least it is like it has to, in a linear manner, it has to go through all the elements in the old array and read it. So at least it is log of n, like that's the downside. But the good thing about the array is the constant is always 1. Like it means that if you have an array and you have data, for example, 10, 20, 30, you could always access any element faster than writing in a node list because you don't have to search it. All you gotta do is you would say, like, for example, my array and index 2, which is 0, 1, 2, and it will give you 30. So the point in this is, like, when you design a stack, you need to think, like, do you need a stack that you can have a fixed size and you can read and write faster, or you can have a stack that you can insert elements at the end of the node and size that. I mean, size always matters, but you don't have to worry about resizing the node list. So you would have for example, a node list of like singly linked lists or doubly linked lists, or you would have all these nodes and you would keep adding, and then you will have a pointer that will be it will be just tracking which one is the last element. So, and we will talk about that in a bit. But the point here is, first, like, the first decision you need to make is which one of these is more important to you, and you need to it's good to read before implementing something that you will use in your web application or a backend server. So let's take a look at the stack. What the stack needs to have is, let me clean the screen first. Delete. So when you implement the stack, let's say that we are implementing it based on an array list. So what do? You design like a box with one side open. So that's a box, like a rectangle box, and we have one entry open here. And we know in this box, like if we divide it in multiple parts, for example, if I divide this in 4 parts, this will be the first size. I mean, if I want to put 4 elements, so that will be the first room, this will be the second, third, and that will be the fourth one. But I need to build my wall. Okay, so we know that we want 4 elements in this one, and that's what we design. So it's technically saying like new array, and that array is, let's say, let's put it mostly like a Java code. It has a size 4. So once this is created, you can resize this unless you copy all the data from this one and create a new one that's 2 times bigger than this, or whatever size amount you want to give it. Okay, let's focus back on the stack implementation. So we have an array and its main size is 4, and this actually the length is 4. I want to reserve the size in another vocabulary. So let's say the length is 4. So if I count this 1, 2, 3, 4, so this can hold 4 elements, 4 different data. Like it can be like 4, 1, 2, 3, 4. It can be like John, Tina, Gina, and Khan, something. So the way now I want people to access this data, I want them to limit. And this limitation is what the data structure or algorithm for a stack is implemented. So that means that I only want people to add data, which means push. For example, if someone pushes, let's get a number, 10. So now 10 is inserted, then 20, 30, 40. So when someone inserts data here, it's like one way, and that would go all the way to the bottom. And then the other one would go to the top and all the way to 40 until it's full. So it's the same idea. For example, you have a bookshelf. So you put the first book, you put the second book, third book, and fourth book. The only thing to imagine here is that, let's say this is a box, like you have a box. So once you put all these books, you don't have large space to put your hand down here to get any one of them. For example, this is too tight. You put all these books down. To get this book, you have to get rid of this one, then you remove this one, you remove this one. Once all of these are removed, which means that if I take this, I put it on the ground, on the floor, then I take the other one, then I put that on top of that, on the floor, and then I get the other one. So, excuse me. So I put all these 3 books, I took them in order. See, like it's, for example, that's 10, 20, 30, 40. So now when I removed, 40 was first to be removed, 30 is second, 20 is third, and the last one to remove now will be the book number 10. So pretty much the idea is the way that you implement the algorithm, you do not allow a user to have access like at any part they want. Like you want to limit them in this order. If you have your box, you can call it anything else, but if you have a container and you put the first, it's like just enough that it sits down there, you put the other one on top, and the only to access the last one is to get rid of the books on top of that. So that's the stack idea. That's like real time example. Now you can think about, get some stuff, think about like trays and some other stuff that you can put one on top of the other, and you would only be able to access one of those elements in a way that you have to remove anything that's sitting on top of it. But what happens if you have something, for example, that you can access it at any part? I mean, there are data structures. Like you have 10 books, you can just grab the middle one. In that case, if you have the flexibility of picking up any one of these, removing them or adding there, and that would be a list. That wouldn't be stack. So that's a list that you can add and remove from any part. Okay, let's make sure that we don't get a very long video, and that's the basic idea. So let me clear this part. And 2 more things to talk about this. So we talked about how you want to add, and that's one way, and that's how you want to take it off. The same, like first remove the top. But the other thing to notice is the indexes. For example, indices. So this is index 0, that's 1, 2, 3. Look, the length is 4. That means it can hold 4 elements, but the address for each element starts from 0. It's the same thing as having an array. It's the same thing. Like you have an array. It's 1, 2, 3. Make it this longer. That's okay. So 4. This line is data. This is data that you inserted. But here, this one is indices, like this index 0, index 1, 2, 3. So If you ask me what's the length of the array, I would tell you 4. Length equals 4. So if you ask me what is the size of the stack, okay, don't confuse me with size of array, size of stack. I mean, how many elements I have put in this stack. Let me remove. Okay. So if you ask me how many, for example, I have to have a pointer. Like I have 1, 2, 3. I have 3 elements right now. This is empty. So in this right now, the size of stack is 3. So compare. The length is 4. The size is 3. That means we have 3 elements inserted. So we only care about the data that is in the stack, not the size of the array, because this could be 100, but there will be like 97 of them will be empty. We don't care about the empty array, empty places. We only care about the how many elements we have inserted. So that would be the size of a stack. So that's like how many we got here. Now to keep track of how many you inserted, you want to count them. Like, okay, I put 1, so I have 1 element, for example, that's 1. Then I put it another one, then I would say that 1 plus 1. Now I got 2. Then I insert another one, then that would be plus 1, that would be 3. But we want to have a counter to count that. The way we would do is we would have a pointer. And that pointer, we want to call that top. You can call it top index, you can call it location of top index, whatever makes sense for you. But the way that you want to know how many is inserted in your stack, how big your stack is getting, or how many it has, that would be a pointer called top. So now the top's job is to track this. So we know right now, let me make just a clean one so we don't get confused with too much on the screen. Let's say I have now a stack. I want to put it in an array because I think it's easier for some time to visualize it rather than call it a stack. So I have a pointer. My pointer's job is to know how many data is in my stack. The first thing I would do, there are 2 ways to implement the top. The first one is to point this right at index 0, and the second one is pointed outside of the array, which is -1. Like you would have this gray zone. So for the first one, let's do the gray zone. Both make sense. Whatever will be easy, you can do that. So now my pointer top is pointing at -1. -1 is not part of this array. It's out of the bound. So it does not exist in the. If you try to reach -1, you will get an error. So that's what we want. We wanted to count once we have data. And remember that we have a length, and that was, for example, 4. And now we want to follow what is the size. That's what we want to follow. How many elements we have. So we are going to insert an element. Let's add 10. So we added 10, which we will call it push. So we added 10, push 10. And now this comes here. Now the pointer is -1 plus 1 would give you 0. So now it increments. So we have top index plus plus. So we are adding 1. It's top plus equals plus 1, whatever makes sense for you. So now this is pointing to 10. Okay, let's push another element. I want to add another element. Let's add 20 into the stack. So once I add 20 here, that means my pointer now shifts. Okay, done with this one. Now my top is pointing at 20. So let's add another one. Let's add 30. And that means this goes away. My top now points at 30. So that's the way that you would track how many elements are in the array. So we pushed 30. So we know the length, the number of elements it can hold is 4. So this can hold 4 elements, but we have inserted 3. So that means the size of index at this moment is 3. The length of the size of a stack. the length of the stack or the array that was initialized is 4. So if I put one more, and that will make this full. So that means this pointer gets removed, and now my top index is the last one. Okay, so once we get to the last point, here's the question now. When we add, we have to check, when we push an element, we have to check if there's an empty space. That's why you want to keep track of it. Like how many are there? So what happens if you push something here now, since there's no more boxes left, there's no space in memory, it's not going to get added. So to push first, you need to check if it is empty. And that's one of the method. Let me put it other way. If it is not full, then push. If there is a space in this memory, then push. And that means that I need to check this 3. If 3 at this position does not equal the length, if size or the top index, if the top index does not equal the array length, if it does not equal the array length, that means you can push now data into it. If it does, then just return, don't push anything. Just say you're not allowed to add anything. So then the same rule applies if it is empty. What if there are no data and you want to get rid of something? You want to pop. So instead of saying remove in a stack, you would use the word push pop. So you want to pop something, for example, you want to pop an element from here. But if there's nothing, if it is -1, then you would return saying like, okay, there's nothing to be removed. So you want to test before removing something. If you do pop, for pop you have to say what? If it is not empty, then you can remove it. But if it is empty, then there's nothing to be removed. So a stack would have technically the methods that will be included in a stack is, okay, let me just write it here since this is the last part about the explanation. We will have a push method and pop method to remove and top method to know where our top position index is, and this will also tell us how many elements are inserted. If it is empty or full, and the last thing is size. All these are methods that must be included in a stack. The minimum. You can add more, but that's at least the minimum. Okay, so why would you want to use a stack data structure? If you want to test something, I mean, there are different uses, but one of the simple one is like it can help you. For example, if you have a list that 1, 2, 3, 4, and if you want to check, if you read it from both ends and it has the same data value, which is like a string palindrome, like you would. So this is my array, and for example, my string or whatever you can think of it, or an array. If I want to check like if it has the same value, if I loop this from this side, it would be like 1, 2, 3, 4. But if I implement the stack and read it from the top side, which is the last side, then it will be like, is 1 equal to 4? Nope, it's not. So it's not a palindrome. It does not have the same data. Actually, let me make it clear before I leave this something confusing. Let me add another page. For example, you have race car. Okay, so at both ends, these values match. So for me, an easy way to check is like one string 1 is just race car, And string 2 is a stack implementation of race car. So this is a stack implementation. If I loop through this, and if I implement this in a stack, this is how it would be. For example, it will be race car. So what I would do, you see now, that's where this started. Once I push this, this goes there. A goes after that, the same order. So each one would go like from top to, like it will go from bottom up. And now once I check this, I will be checking from the end. So I will be saying that, is this at index 0 equal to pop last element of the stack? If they are true, then they're a palindrome. They have, if you read it from reverse order, and no matter how you read from beginning or end, it will be the same value. So that's an easy way of implementing or checking it by implementing a stack data structure. So that was the talking about. Let's do that in code. And that will be my lovely, it's called VS Code. So I would say it, let's open it actually. It's good to open the VS Code directly. And I would say new file. I'm gonna call it the stack.java, and we would say public class stack. We want to implement the generic because we can use it multiple times. We don't have to, but for this tutorial we will do a generic. So what we need, we are going to be implementing an array base. That means it will be like private t data. So remember, like right now this t is like whatever your user gives, convert this array to that one. If it is a string, it should be in a string array. If it is an integer, then it should be an integer array. Then we need another one. We would call this top. Let's call it top index location, which is similar. It is similar to saying top, and we will be integer because we are tracking the index number. So we're tracking the index location. This one, we are tracking, so it should be integer number. Okay, you can instantiate it right here. You could say, like, for example, top index equals 0, or it equals -1, or you want to do it on the instantiation time. So let's do it on the second method. It would be public stack, and if user does not give any size, that means we want to give it a default size because you can have an empty array in Java. So that will be data equals to, we will convert this here to array type, new object, and that object would be an array object, and size will be 100. Okay, so you know that in Java you can't have an empty array list, but what we are doing is because when you do a generic data type, it has to be an object. You can't do it on a primitive data type, so it has to be an object. Like primitive data type, for example, you have int and double, all these things, but you need object type, which is like integer, like object wrapper, because they have more elements to do the conversion and stuff like that. And it gives you this error kind of once you run the code. You can do this separate warning called unchecked, and we will see why we did this later. Okay, the other thing you want to do is instantiate the top index too. So we would say top index location equals to -1. Okay, once we get to pop and push, then we will say why you can do -1 or why would you want to do the 0. Okay, so let's do another one for this. I'm going to copy paste this part, because this constructor we want to have the user to give it a size. we would say int maximum size given by user. Yeah, that's how you instantiate an array. Maximum is spelled wrong, so that would be maximum size given by user. This one is, we want a user to give a size, because you have to say like new int, and that int has to have a size, otherwise it won't work, or a string. So, and that's the, if a user decides to give it, if a user gives the size on instantiation. Okay, and now we want to add the other methods. So a stack has to have to check if it is empty, if it is full, and push pop all these methods. So let's do that. The first one would be, let's say if it is empty, public boolean, let's say is empty, and all we gotta do is, there's the shorter version. The shorter version is return if top index location equals to -1, because that's where we started. That's -1. If it is -1, it's empty. Or this thing is equivalent to saying that if top index location equals -1, in this case return true because now it is empty, else return false. But we can just do the first line, so we don't have to do, because it's going to check, it is going to return either true or false. And one of the things you can always do is, I encourage you, if you do Java shell, and you can say like int a equals 1 and b equals, set it to 2. If I say like is a equal to b, false. So if I say b equals to 1, if I say is a equal to b, it's going to be true. It's the same concept. Okay, let's do the full method. The same idea. Public boolean is set full, return now top index location equals to data.length -1. Here's the tricky part. Since we started at -1, that means it's going to track the index location, and index location is for the last element. It would be index.length -1 would give you the last element in an array. For example, this is 4, but the index location for 40 is -1. And that's the same thing. Like we started at what? At -1. That means this whole length is now -1. So you can either do this one, or you could just say like, common way, like top index location plus 1 equals to length. That means instead of starting from negative, you would start from here. So that's like 0. So we would say like 1, 2, 3, 4. If 4 equals 4, then that's true. And now we have implemented the first part, and let me put the other one too, so just in case sometime if you want to use one or the other. So we know it starts at -1, so the length would be -1 to negate that -1 that we started. Okay, so now we will go to push or the top method. Let's do the top first. We would say public t top, give me the top element. Remember, this t is whatever the data type it's created on the instantiation time. Whenever you create a new object based whatever you give the type, this will be that one. So we want to return what is the last element here. Sorry, we want to see what is here. Like this top is what it is pointing at. We want the data, not the index. For index, we have the top index location, but we want the element, the data. So we will say that if it is not empty, I mean, with algorithms, you can always return write different ways. So I mean, just probably practice whatever you like to stick to one of them. If it is not empty, return data of top index location, like the last element, wherever this index is at, return. But you definitely don't want to go to -1 because it's going to give you an error. And so that's the top location. Else, you can do else return null. I mean, it's one way or the other. But we can use null because we are using a Java object. We are inheriting that. That means this is an object wrapper, as I mentioned up there. Like it's the integer type. We can use null. And you can change your code. You can refactor it, saying, for example, if it is empty, return null. Else, return data top index location. So it would be like, for example, if is empty true, if there's no data there, return null. And if that didn't pass, then return top index location. One way or another, it all does the same thing. If it is empty, it's gonna stop the code line right here. Returns a null, it stops. If it is not empty, then it's gonna return the data that exists. So let's do the push method. We definitely want to have data there, public, and that would be void because we want to push. We don't care about what if it pushed or not for this one, but a void push, and that would be t element. You can call it data, you can call it like new data, you can call it like whatever you want to call it. I'm gonna call it element because we're using an array. If it was a node, I would call it a new node. So to push, we want to check if it is not full. That's what we are worried about. If it is full, you should not push anything. But if it is not full, then we can push an element. Say that if is not full. I mean, you can always rewrite the algorithm. If it is full, return null. I mean, let's do that. If it is not full, then, or let's say this one. That's easier to understand. If it is not full, all you gotta do is, remember now, we're starting at -1. That means -1, you can't push there, so you have to increment that. That will be top index location plus plus. First, we increment. And now we would say data top index location. Now it is incremented, so now the pointer is pointing at index 0, and that would be element. Add this element at that location. That's it. Or you can write it in a shorter version. If it is not full, then you can. If it is not full, you would say like data plus plus increment first top index location, and that would equal to element, to the whatever is the new data, whatever you like, and however you want to change. And the reason we don't care about else because it is a push method. If it is not full, then add it. If it is full, then you can't do anything about it. Okay, and let's do pop. Pop is a little bit two ways of implementing. Sometimes you would see like the libraries that they implement, like for example packages in Java, it returns the data once it removes it. So first let's do the void one, then let's do the returning too. So we would say void pop. We want to remove, so we don't care what is here. We don't care about it. We just want to remove it. But you won't want to remove, but before removing, we know that now the index has incremented, but we need to de-increment, like get rid of that index. So we want to remove this, and that means that what I gotta do is, first, I want to remove this. And the second thing I want to do, I want to set this to a null value, because if I don't do that, it will be in the memories. I want to get rid of that. And then I want to remove this top pointer. Now it's removed there, and I want to point it down here. I would say that my top is now here. So now that's now if I don't do that, that means the data stays in the memory. But if I do give it null, the Java's garbage collection will come check this and take it out of the memory, free memory. So first we would say top end data, which is located at top index location, that is equal to null. Get rid of that first. Then we would say top index location minus minus, and that's pretty much the code for it. But we have to do two more things. We have to check if it is null or not, if it is empty or not. We would say if is not empty. Let's see if it is empty. If it is empty, return. That's it. Don't do anything, just return, because it's a void method. Otherwise, if it was not empty, then set it to null, then get rid of the index. So now the index will be pointing one to the left, or you could just do it in one line. You would just say like index position at this position, set it to null, then get rid of it in one way or another. Okay, so the second way to do this is to get the last data before removing it. We will do this in a little bit more lines of code. We would say whatever you want to remove, give me that back. I would say that if is not empty, which one you want to use? Okay, if it is not empty, let's do this. If it is not empty, if empty is false, then I can create just the code here. I can put it outside, but let's do it here. You can change the code. I highly encourage you. The type is T. That's the same way of saying a string. Let's say element to be removed. But definitely, this is a T type. Element to be removed equals to data at top index location. Okay, we save the data first. Now once it is saved, the same game, data at top index location equals to -1. Oh, sorry, I was thinking about something else. Equals to null. So now it is null, removed. Now we want to move the pointer back, the top pointer. We need to move it back. The top index location that is pointing, we set it to null. Now we want to point it to the element that exists there. We would say top index location minus minus, or equals, or this one. But let's do the minus minus thing. Okay. Now once it does that, we would say return the element that we were going to remove it. Okay, so that's the first part. If it is not empty, if it is empty, else return null. So if we could just write it, if it is empty, return null, then do all this code, or this way. I mean, you could do that. Change the code. At the end of the day, it's about how you prefer and what you like. And you could also short it by saying like top index minus minus equals null, and you could also say like return in one line. But I don't want to make it more complicated. So the last thing to do is we did pop top. Let's do the size. So we talked about size. We know that type is integer because it's the one that keeps pointing. 1, 2, 3, 4. Like how many is inserted, how many elements, size. And now we say return top index location +1. We do +1 because it's negative. It starts from negative, but we want to count from like 1, 2, 3. So, and it is important because it will give you the exact size, not the index location. So let me point out, let me say. So we say that we start from 0, like the location is like 1, 2, 3, 4. So what we have 4, the size is 4, but if I count an index it would be like 0, 1, 2, 3. But if I want to get the size, then I would say like 3 plus 1, that would be equal to 4. Okay, let's test this code that we wrote to make sure that we wrote it in the right way. I'm going to create a new file called tester, stack tester, driver, whatever you like to call it. And now I'm going to call this a main method. Okay, let's call the first stack. This is important. You see that we are giving it integer wrapper, like we are giving it an object. My numbers equals to new stack. If I don't give it any size, it will be 100, but I want to give it a size, let's say give it 3, so we know that it is doing its job. My number list dot push 10. Excuse me, I need some water. Okay, 20, 30. Remember, this is what it is doing, and that's where sometimes students get confused. So what happens, 10 sits at the bottom of the stack, 20 goes and sits on top of it, 30 goes and sits on top of that. That's how it is implemented right now. So that's 10, 20, 30. When I say top, it should give me 30. So let's say system dot out and give me my numbers dot top. Yeah, let's print this, run it. Okay, that's 30. Now I want to remove 30 from the list. That would be my number list. Remember, there's no for loop in a stack, so you don't do a whole list to show all the elements. Otherwise, you will be implementing a list. Okay, so that would be my number. Let's say pop. And now I'm going to call this again. Now it should point to 20 if the code doesn't have any problem. Yeah, so what we did is now the top is, let's call this top. Let me add this. This is top index. Okay, what happened? Now show me the browser. Okay, so let's add this one now. So we know that top is now pointing, it was first pointing at 20. It's line 13. Let's add line 13 just to make it clear. Okay, so that's 30 now. That's been removed here, line 14, and now top is pointing at this one at 20. So if I remove it one more time, my numbers dot pop, and now I copy this, bring it down. Should get rid of 20 and point to 10, but we want to go all the way down to 0 to see if we can catch the error. And the same thing. Okay, now it is null because we have, if it is empty, then give us null. It removed all 3 elements and it give us null. Okay, so here's one more thing. Why we also implemented to return the data. Once we remove, we can return the data. To do that, let's test that one. I want to say that it's a number. You can say integer, but int, it doesn't matter. Int my to be removed. Remove the element equals to, let's say, my number list dot pop. But if you have different types, you gotta do conversion. If there's a huge change, like you have to cast it, but it's not a big one for integer. So now if I do system.out, it should give me 30 because that's what's sitting at the top element. So let's see, system.out, remove element. So the way you want to implement this one is, you want to know what you remove, then you can use it with something else or compare. Like string palindrome, you want to remove the back element, then you want to compare it. So this is the way that if you want to prefer to get the element that you're removing. Okay, so we passed the test, it went to negative, but now you want to test what happens if it is 30. Okay, I want to add this 40, and I want you just to tell me, talk to yourself, what is going to happen. What will be the top element? We have the size 3, so we got up to 30. What's the last element? If I do system out my number list dot top, what do you think is going to print? It is important. Let me see. It printed 30. You know why? Because there's no more place. So once it is 40 here, the one that you're trying to add it's out of bound. It doesn't even care. And we say that like, if there is no space, just don't do anything. You could add the warning that there's no more space, but that's what it does. So it added, but now you want to check what is the size. Let's do the size. Excuse me, and my number list, that size. I want to know how many are there. And it will tell me it's 3. 1, 2, 3. But now I want to add 40. I increase the size there. So now it is 4. And you remember that index was -1, so we added 1 to get the real size. Otherwise, you would get the index for the last element. So that's 4. Okay, why we implemented a generic one? The good thing about generic is, for example, I needed number, I used that as stack for number. Now I need like characters, or I need a string. I would just say like a stack string name list equals new stack. I could write a string here, but you don't need it. And let's say the size is 3, for example. Then name list will be, or guest list, yeah. It will be push, and the first person to be added is John. Okay, what am I doing? Where's my shortcut? It's Kim. Now, okay, so now if I print the top one, then it will be, for example, system out dot, what is it, my number list, not my number list, name list dot top should give me the last one. So try to practice this. If you have any question, you can leave a comment. I will try to answer back. And there's, I think I also wrote the same article on try to explain it on Medium, which I'm trying to do it a little bit more. So these are differences that you can practice with it. And if you still have question about stack, please leave a comment. I will try to get back to you. And the reason we implement generic is to save ourselves some time from creating different type of stack, like integer, then a string, stuff like that. So that's it, and that's it. That's all about stack. I hope I didn't forget anything, and if I did, please